Hi, everyone. Welcome to the lesson 2 of the last unit, mad props. I'm going to give you some mad props. All right. Wonder why they call it that. Maybe because you feel mad afterwards. No, actually, I like these ones. These are always fun for me. So if you, and we are on page 185. If you're following along in your book, which you should, your book should be open to page 185. So M3 185. And yeah, please don't write your answer in the chat because we don't have that available for you right now. So if you take a look at these, you need to identify the property of power associated with each example. And if you notice right here, I wrote down the products up, the rules up here, just as a quick, reminder, because I don't even remember all the rule names, right? Because they're kind of, I just know what they are. I just may not know what the rule names are, right? And so if you notice right here, this is 2 to the 5th power times 2 to the 2nd power. And notice what we do to those exponents. We add them up, right? So that is the product rule. That's what tells us that. These are, hopefully you know these. And then 2 to the 0 power is the 0 power rule, right? Because anything to the 0 power is what? Equal to 1. And then if we have something that's dividing, same basis, but dividing, what are we doing with those exponents? We are just going to subtract them. So 14 minus 5 will give us a 9. Okay, another way to think about it, just more like conceptually, if you have 14 2s on top and 5 2s on the bottom, how many of those can we cancel out, right? 5 of them. And then what do we have left? We have no more 2s left on the bottom, but we have 9 left on the top, right? So anyways, this is the quotient rule, right? Because we're dividing. And then this one, I liked somebody in one of my classes said that this was the name of the rule. I'm like, I like it. So if we have the 0 power rule, then it makes sense to have the 1 power rule, right? Where 2 to the power of 1 means what? It's going to be whatever the base is, that's what it's going to equal, right? So the base to the 1 power is going to equal the base, right? So that's not an official term, but we'll just use that in this class, okay? And so our learning targets for today are going to be expanding logarithmic expressions. Expressions are different than equations because expressions have no equal sign. And equations obviously have equal signs. Using properties of logarithms, and we're going to learn about that very soon. And rewrite multiple logarithmic expressions as a single logarithmic. So basically, we're going to condense log expressions. We're going to expand them and we're going to condense them, right? All right, so here we go. So we're going to go on to show what you know, right? So looking at all these guys, I try to color coordinate these. Again, if you did not do these problems in class or you were not in class today, make sure you try to do them without me, because technically you should. And then you can listen to the explanation. Press pause. All right, so if you take a look here, this is 4 times 6, because this is all just multiplying, right? So it's going to be 24. And then if you look at just all the green ones, those are the x to the 5th power times x squared times x. Notice all those x's are multiplying. So how many do we have multiplying altogether? We got 5 plus the 2 more plus that third little one right there, right? That's 8 x's that we're multiplying. So it's going to be x to the 8th power, right? And then for the y, we just have y to the 6th plus the one more little y over there. That's y to the 7th power. Okay, so that's our answer. That's it. All right, the next problem right here. For me, what I like to do is I like to just cancel things out right away if I can, right? But another way to do it is just to multiply straight across first and then start canceling things out. So that's a little bit more, in order. There's a little order to this, right? So 42 times, and then if it's m to the 5th power and add times n to the 4th power, just like what we did up there, that means we're multiplying 9 m's, right? So an m to the 9th power. And then here, n to the 3rd power and n to the 2nd power, that's going to just be together. Their powers combined. That's going to be n to the 5th power. Right? And on the bottom, I'm just going to, copy that down. And what can I cancel out? The n to the 5th powers, right? If I have 9 m's on top and 6 on the bottom, right? 6 on the bottom. And how much can I cancel out? I can cancel out 6 of them, which means I only have 3 left on the top, right? And so that's why we have m to the 3rd power. Oh, and how did I get, why am I working backwards? I don't know. But how did I get the 7? 42 divided by 6, right? And if honestly 6 didn't go in there evenly, then I would just figure out, well, which number goes into both of them and divide those out. All right, so this would be the answer. So, oh, we didn't talk about the properties. So what properties did we use? Well, we used the multiplication one. So the product property. What else did we use? Technically, this is because n minus, so 5 minus 5 is 0. So technically the zero the zero, what is it called? The zero power rule. And then we did use some division here. So it's the quotient. Okay, I'm not really writing this in order, but you know what I mean. So this is the quotient rule of powers. I'll just go with the quotient rule, right? For this top one right here for A, what did we just do? It was literally only one, just the product rule. Sorry, I should not say property there. I should say rule. Like, what's the product property? The product rule of powers. All right, and then if you look at right down here, this is negative 3x to the 7th y cubed to the 5th power. So if you notice right here, to the 5th power includes all of we're going to do to the 5th power of everything. Because if you want to really think about it, what does this mean? There's negative 3x to the 7th y cubed times negative 3x to the 7th y cubed. How many times do we do this? 5 times. This is literally what it means. Negative 3x to the 7 y cubed. We need to do it one more time. Negative 3x to the 7 y cubed. Right? So how many 3's are we actually, negative 3's are we multiplying? 5 of them, right? So negative 3, 5 times. So it's going to be negative 243. You can do that in a calculator. You don't need to do that, like memorize that or anything like that. Unnecessary. And again, how many x's do we have? 35 of them, right? There's a lot. That's what we're multiplying. This power to a power, which is multiplication. So 7 times 5 is 35. And for the y, it's 3 times 5 because we have 5 groups of 3, right? So that's going to be 15. So that should be your answer. I try to color coordinate them-ish. All right. And then we're going to do a whole bunch of skipping. I'm going to page 189, but you don't have to go to that page. I just chose that page because and I had a lot of room. So here in the book, they do a lot of like proving, and they're going to show you why these properties hold true. We're just going to go to like, you know, making these connections, right? So if you notice right here, on the left, we have our exponents. And these are the properties that we've just been talking about, right? The more explicitly. So when we're multiplying the bases, what are we doing? The exponents? We're adding them. And when we're going power to a power, what are we doing? We're going to multiply those exponents, right? And then same thing with the quotient rule. When we're dividing them, remember, assuming the same base. If they have different bases, we cannot do anything with them, right? But if they have the same base, then what are we doing with those exponents? We can subtract them. And those are the patterns we found, right? And then the zero power rule is b to the 0 is 1, right? So if you notice right here, remember logs are what? Exponents. Logs are just exponents. So if, remember our argument right here is m times n, then what do you notice? What are we doing? We're just, it's the same thing as adding our logs, because that's adding our exponents, the same thing, right? Is this m plus n business here, right? So we need to show the log base b is going to stay the same. And then we just split them up, just like that. So we can write them in 2 different ways. This is like the condensed version, and this is like on the right is the expanded version, okay? Why are we learning this? Because later on when we're trying to solve like log equations, this will come really, really useful, come really, really handy is what I meant to say. But it's the same thing as useful, I suppose. But yes, so the more we practice this, the easier it will be for us to recognize them and rewrite them, and then make it easier for us to solve problems, okay? So if you notice right here, oh, and if you notice on top, we did a little like, we checked to see if this was really true, because m times n, if you want to think about it like this, is basically log of 2 times 5, right? Well, what's 2 times 5? Log is 10, right? So what we're saying is that the log of 10 is equal to the log of 2 plus the log of 5. If you don't believe me, try it. See if I can do that. I will get there. 1 second. I'm going to go get Desmos. Did you get Desmos? All right. So if you notice right here, I got Desmos. Look at this. So log of 2 times 5 is 1. Well, also log of 10 is 1. So they're the same thing. And the log of 2 plus the log of 5 is what? 1. Here's my little sweet proof here to show, yes, it's true. It works. And you could do that with any of these numbers. So even if like log of, let's do 20, right? Log of 20. Well, how do we get log of 20? It could be log, well, it's 4 times 5. We could do 4 times 5, right? So we could go log of 4 plus the log of 5. And what do you notice? The numbers are exactly the same. Like what? Well, then what about 2 and 10? Because 2 and 10 also equal 20, right? 2 times 10. So let's try that out. So log of 2 plus the log of 10. What? Do you see how they're exactly the same? This is what I'm talking about. Is that not cool? I think it's cool. Maybe it's just me. All right. So again, same thing with here. If you're looking at the power rule, right? So notice when we're going power to a power that the B and the M and the N are multiplying, right? So remember, what is a log? It's an exponent, right? So if we have this exponent right here of N, what do we multiply it with? Well, obviously the other exponent. What is the other exponent? The log, and that's why it's here. So do you see how here's the N right here, and we're multiplying with the other exponent, which is the log. Do you see how that makes sense? Hopefully it makes sense. So what I like to think of, I'm just going to put that exponent out in front. Okay. And then for the quotient rule, notice that this is M minus N. So same thing here. We're just going to subtract them, subtract the two exponents, right? So log base B of M is equal minus log base B of N. All right. And then log of B to B of 1, log of base B of 1. So what I like to do, because technically this was like, you couldn't see this, right? Because remember it was invisible if you were in class. So remember, we're going to just convert it to exponentials because it helps me to understand better. So we're going to go, this is B1, and this is the question mark that we don't know. This is our question mark, right? So B to the question mark is equal to 1. Well, what would make it equal to 1? What does that exponent have to be? The only number it could be 0, right? So that's why we're saying that the log of any base, it does not even matter what base 2, base 3, base 4, base 5, base E, right? If it's of 1, it has to equal 0. Like, because that's the only thing that would make sense. See what I'm saying? So if it's like log base 3 of 1 is equal to 0. How do I know that? Because here's my triangle of power. So 3, 1, 0. So it's 3 to the 0 is equal to 1. See? All right. And then we're going to do some more skipping. Okay, right here. So we're going to be on page 191. And this is just us practicing it. And I just snipped out the properties right here. So they're here on the right-hand side. And if you did not take a picture of that or like snip that out in your onto your computer and have that available for you, I would definitely write those down. Write these properties down because that will help you as you look at it. Or just remember it either way. And so again, if you have not done these before, please work on them, try them out. Yeah, press pause. All right, here we go. So again, log base 4, I know is going to stay the same. And I notice that these are multiplying. So I am going to have to separate them out by a plus, right? So it's going to be 6 log base 4 of 6 plus log base 4 of x to the 5th power. But I do know that the 5th power, what do I do with that? Bring that to the front, okay? So this is what it's going to look like all expanded out. So this is what we call expanded form. Why? Because it's expanded. It ate a buffet. It needs to like expand. I'm just kidding. All right. And then we'll do the C next. So if you notice right here, this is just going to be natural log. So remember, natural logs are logs too, right? So we're treating it exactly the same way. So natural log of 3, remember it's multiplying. So that means we have to add natural log of x. And then we're going to add, right? Because that's still multiplying, natural log of y. Remember there was a 3 here, but we brought that up to the front because that was an exponent. And what do we do with exponents? Multiply with the other exponent, which is the log. Okay, so this is where that 3 went. Okay. Maybe I should have like, oops, did too much. So there we go. So that's what that's going to look like. That should be your answer. If you take a look at B, right? B, I like to just always do these in order. Honestly, I'll just do these again because I think it makes more sense when I write it as I say it. So again, we're going to start with log base 7, right? And I know that I have a 3 there, so I'm going to separate that out. 3 and the y are what? Multiplying. So I know that's going to be add. And again, it's log base 7 of y to the 4th. But remember that 4 is an exponent, so I'm just going to bring it up to the front. Okay, just like that. And then now I'm dividing. What am I dividing? An x to the 3rd power. So remember, dividing means I'm going to subtract. So minus log base 7 of x to the 3rd. But remember that 3rd, what do we do with that 3? Multiply it with the exponent. Oh, that looks terrible. Let me just write that again. Log base 7 of 3 plus 4 log base 7 of y minus 3 log base 7 of x. There we go. Just like that, right? And now we're going to practice some more. Look at number 2. Try A, B, and C. I'm assuming that you've paused and you've tried these out yourself. So again, now we're going to condense them. We're going to make them into one log, okay? So I know we're definitely going to start with a log base 2 because both of them are log base 2. So we can condense them now. And it's multiplying, so I know it's going to be 10 times x, right? But remember that 3, that's the exponent for the x. So we're going to just include it only for the x. So it's just x to the 3rd power. So don't forget to put the parentheses around the whole thing because that is our argument right there. Okay, so this is that's it. All right. So now let's see if I can like color coordinate some of these as well. So if we look to the right, I'm going to look over here with the log right here. So the 12 right here is this 12, right? And then it's to the 4th power. So here's the 4th power right there. And then we got the 2, which was this 2, right? So it's, how do we know it's underneath? How do we know it's divide, right? Because of that minus, right? So let me do that with green. So this minus right here is showing me that I need to divide, okay? And then we're gonna have that exponent of 4 is this exponent of 4 right there. See how they're all related, all right? And then, I mean, can you leave it like that? Yeah. Can you figure out what those numbers are? Yeah, you can figure that out using a calculator, right? We can, however, simplify this a little bit more just because we know that the exponents are the same. So we know that that's the same as saying, well, 12 over 2 to the 4th power, right? And yeah, because if we were to distribute this back out, so 12 to the 4th, here's 12 to the 4th, 2 to the 4th, 2 to the 4th, see, same thing, right? And then do we know what 12 over 2 is? Yeah, 6, right? So we can technically say this is log of 6 to the 4th power. I know, crazy. And there was another way that somebody else did it, which I liked, and they noticed, oh, well, the 4s are the same, so I'm just going to divide first. Like, that's a great idea. So 12 divided by 2, which is 6, right? And since the 4 was in the front, right, now we're going to put in that exponent. And you see, you still get the same thing. This only works if you have the same exponent. There are different exponents. There is nothing we can do about that, okay? So for example, if it was like, oh, probably don't want to write that. Let me try this and erase that. So for example, if it was 3 log 10 minus 4 log 5, let's just say, you would not be able to do this like what we did there, like 10 divided by, because if we did 10 divided by, so log of 10 divided by 5, right? Then what exponent would we use? Like they can't do that, right? So this one would be a little bit different. It means the same idea. So I'm just going to go 10 to the 3rd power, right? You just bring that back to the exponent and then divide, since that's minus, that's just going to be 5 to the 4th power. That's it. I mean, we could technically figure out what these numbers are just by using our calculator, but that's what it would be. Okay, we wouldn't be able to go the shortcut way of, oh, let's just divide 10 divided by 5 first. Can't do that because our exponents are not the same, because like, which one would you use? Right, so this is what that would be. All right, that was a whole just another problem right there. And here, this was interesting. So let's look inside the parentheses. We've got to do those first. So we're going to go natural log, right, of 3 divided by x, because, you know, that's subtraction. And we're going to bring in that cube right there, right? So there's that cube right there. So let me just highlight that. So there's my 3. And then we're going to do the same thing for the second one, right? So it's just going to be natural log of x divided by 9, because it's a minus. There we go. Now we need to now combine, because we want only 1 log and we have 2 right now. So we want to combine them. So what I'm going to do, I'm just going to simplify this left-hand side for, you know, just to make things a little easier. So 3 to the 3rd power is 27. 3 times 3 is 9. 9 times 3 is 27. And then the bottom right here is x to the 3rd power, right? So now I'm just going to multiply them. Do you see how I multiply them right there? And notice that the 9 and the 27 and 9 is 3, because how many times is 9 going to 27? 3 times. There we go. And then we have an x up here, 1x up here, and 3 x's on the bottom. So I can cancel out up to 1x. That's it. And how many x's do I have left? 2. Where? On the bottom. So see how it's still on the bottom? There we go. Done. Yay, happy days. That's how it's going to go. All right. And that is the end of the lesson. So please, if you have not tried out the exit ticket, try it out. See if you got it right. If you understand it, you got to check your understanding, right? Because you can be like, oh, in this video, yeah, totally makes sense. Totally makes sense. And then be like me, we're like, when I was a student, I'm like, wait, what did we do now? You don't want that. All right. I'll talk to you guys later. Bye.